On to problems 4, 5, and 6. So problem 4 says, in each of the following, y is equal to u of v of x and u of x is given. We want to find a possible formula for v of x. So that is, we want to decompose the given function. So let me just give you a warning really quickly. You are absolutely going to need this if you end up taking business calculus or any other kind of calculus class. You'll need it for the chain rule, amongst other things. So just a heads up. Okay, so y is equal to e to the x squared plus 1, and u of x is e to the x. So we're given that y is equal to u of v of x. Okay, so I want to find something that I can put inside of u of x. So I'm going to say that u of v of x is going to be e to the v of x, so that we get e to the x squared plus 1. So what do we think v of x needs to be? So maybe we want to find v of x. So I've got a v of x here and an x squared plus 1 over there. This means that v of x needs to be equal to x squared plus 1. Okay. For part B, we're given that y is equal to the natural log of 2 to the x plus 1 plus x plus 3. And u of x is the natural log of x plus 3. So we want v of x so that u of v of x is the natural log of v of x plus 3, and that's going to be equal to y. So this is going to be equal to the natural log of 2 to the x plus 1 plus x plus 3. So I've got v of x in here, and on the other side I have 2 to the x plus 1 plus x. So this means that v of x is going to be equal to 2 to the x plus 1 plus x. Okay. On to problem 5. We are supposed to fill in the blanks using the table below. So there's some new notation here that we haven't seen yet. In particular, well, why don't we, you know what? Here's what we'll do. Let's do A and B, and then we'll talk about C and D. So I definitely know how to find g of negative 7. I'm going to go to x is equal to negative 7, and then the output is 13. Okay, so now I want to find g of blank is equal to 11. So I'm going to go on my table and figure out where I see an 11. So this means I have that g of 2 is equal to 11. So the 2 is going to go there. Okay, for part C, this negative 1 exponent, we need to be very careful with this. So another warning. So g to the negative 1 is called the inverse of g. Which we're going to talk about more in the next video. I guess it'll be section 4.6, day 2. But g to the negative 1 is the inverse of g, not necessarily 1 over g. So we need to be really careful with that. So what g to the negative 1 of blank equals negative 7 is asking me is, what do I plug in? Okay, how do I say, how do I word this? I guess what I want to say here is that, like, this flips. So, okay, before negative 7 was the input and 13 was the output. When I take g inverse, the new input is 13 and the output is negative 7. So for inverses, inverses flip or swap the inputs and output. Of the function. So maybe the more mathematically correct way to say this is it switches the domain and range. So this means that g inverse of negative 11, g inverse of 11 needs to be 2. Because just like in parts A and C, I'm going to flip the input and output. Okay, so finally, for problem 6, we want to fill in the blanks. So f of 0, I guess, first of all, this graph didn't come out very nice. This is supposed to be f of x. So if I go down and draw in f of 0, it's right at the origin. So the f of 0 is equal to 0. We can also find f of a, right? I know how to do that, hopefully. I'm going to go to x equals a to find f of a. I'm going to touch it with the graph, and I get b. So f of a is equal to b. This means that f inverse of b needs to be equal to a, and that f inverse of 0 needs to be equal to 0.